Imagine the sun peeks over the horizon, casting its first light on the ancient landscape of the Mesozoic era, 66 billion years ago. The swamps and coniferous forests of what we now call Mexico's Yucatan Peninsula are bathed in golden rays. The Gulf of Mexico's warm waters are bustling with vibrant marine life. This prehistoric paradise is alive with the sounds of dinosaurs and gigantic insects, filling the air with their squawks, buzzes, and whirs. But on this very day, the curtain is about to fall on the age of dinosaurs. What could have possibly unfolded on this day of destiny? Let's dive into this dramatic tale and uncover the mystery. Picture yourself standing somewhere in North America, 66 million years ago, gazing at the evening sky. At first, you notice what looks like a star, but as you keep watching, it grows brighter, hardly moving. This isn't a star. It's an asteroid hurtling toward Earth at a breakneck speed of 45,000 miles an hour. The asteroid's rapid approach compresses the air in front of it, heating it to a violent degree and blasting a hole through the atmosphere with a supersonic shockwave. For a few dramatic moments, this fiery ball blazes through the sky, outshining the sun. Then, in an instant, it slams into the Earth with the force of over 100 trillion tons of TNT. The impact pierces Earth's crust, creating a crater more than 115 miles wide and vaporizing thousands of cubic miles of rock. This catastrophic event triggers a domino effect of global disasters, wiping out 80% of life on Earth, including most of the dinosaurs. The age of the dinosaur ends in a blaze of fiery destruction, reshaping our planet forever. This cataclysmic story has fascinated everyone ever since the asteroid impact theory was introduced in 1980. The discovery of the Chicxulub crater in the Gulf of Mexico during the 1990s pinpointed the exact when and where of this ancient disaster. Yet, the mystery of how the aftermath led to such massive extinctions remains captivating. What we do know is that this event marked the dramatic end of the Cretaceous period and the dawn of the Paleogene period. In 2016, a group of British scientists embarked on an offshore drilling mission in the Gulf of Mexico, retrieving the first ever core samples from the peak ring of the Chicxulub crater. This ring, formed when the Earth rebounded seconds after the impact, created a striking circular structure within the crater. By examining this chaotic geology, researchers hope to unravel the extraordinary forces unleashed on that fateful day, shedding light on one of history's greatest mysteries. About a decade ago, scientists at Los Alamos National Laboratory harnessed the power of the mighty Q machine, one of the world's most powerful computers at the time, to simulate the effects of the asteroid impact. The result? A mesmerizing, slow-motion, second-by-second, false-color video that brought the cataclysmic event to life. Within 2 minutes of the 6-mile-wide asteroid colliding with Earth, it carved out a crater 18 miles deep and hurled 25 trillion metric tons of debris into the atmosphere. Think of a pebble splashing into a pond, but on an epic planetary scale. The Earth's crust rebounded with such force that a peak taller than Mount Everest briefly jutted skyward. The energy unleashed was equivalent to more than 1 billion Hiroshima bombs, yet the explosion bore no resemblance to a nuclear blast's iconic mushroom cloud. Instead, it produced a rooster tail, a colossal jet of molten material that soared beyond the atmosphere, some of it raining down over North America. This fiery debris, several times hotter than the sun's surface, ignited everything within 1,000 miles. And if that weren't dramatic enough, an inverted cone of liquefied superheated rock erupted, spreading outward as countless tektites, red-hot blobs of glass, blanketed the Western Hemisphere. Now imagine yourself, if you were close by, say within 1,000 kilometers to the point of impact, your fate would be sealed in an instant. The fireball would engulf you, killing you within seconds. If you were close enough to witness it, you wouldn't stand a chance. 9 seconds after the collision, anyone within that radius would be incinerated by a wave of thermal radiation. Trees, grass, and shrubs would spontaneously ignite, and people would suffer third-degree burns over their entire bodies. But the nightmare wouldn't end there. The impact would trigger a colossal tsunami, towering up to 1,000 feet, depending on the landscape. And if that wasn't terrifying enough, the earthquake following the impact would register at a staggering 10.1 on the Richter scale, more powerful than any quake humans have ever recorded or felt. Rick Astor, a seismology professor at Colorado State University, explains it best. A seismic event of this size would be the equivalent of all the world's earthquakes over the past 160 years going off simultaneously. Now, here's a mind-blowing twist for you. Some of the debris from the asteroid impact actually escaped Earth's gravitational pull and began orbiting the Sun in erratic paths. Over millions of years, these bits of Earth found new homes on other planets and moons. Mars, for example, ended up sprinkled with this ancient rubble, much like we've discovered Martian rocks on our own planet thanks to asteroid impacts. A study published in 2013 in the journal Astrobiology estimated that tens of thousands of pounds of this impact debris may have landed on Titan, Saturn's intriguing moon, and on Europa and Callisto, moons of Jupiter. These are all celestial bodies that scientists consider potential habitats for life. Even more fascinating, mathematical models suggest that some of this wandering debris might have carried living microbes. So while the asteroid devastated life on Earth, it might have also spread it throughout the solar system. Now, what about the asteroid itself? Upon impact, it vaporized completely, merging with vaporized Earth rock to form a fiery plume that shot halfway to the moon before collapsing into a column of glowing dust. Computer simulations revealed that the atmosphere within 1,500 miles of ground zero became scorching hot from the debris storm, igniting massive forest fires. As the Earth rotated, this airborne material converged on the opposite side of the planet, setting the entire Indian subcontinent ablaze. The ash and soot layer left behind tells a grim tale. Around 70% of the world's forests were consumed by these colossal fires. But the real catastrophe had just begun. Scientists are still piecing together the details, drawing from computer models, field studies of debris layers, extinction rates, fossils, and microfossils, yet the overall picture remains bleak. The impact's dust and soot filled the sky, blocking sunlight for months. With no sunlight, photosynthesis ground to a halt, killing most plant life and wiping out the ocean's phytoplankton. The result? A dramatic drop in atmospheric oxygen levels. Once the fires burned out, Earth plunged into a frigid period, possibly even a deep freeze. Both essential food chains, on land and in the sea, collapsed. Around 75% of all species went extinct. More than 99.9999% of all living organisms perished, bringing the carbon cycle to a standstill. While many stories highlight the explosive violence of the first moments and days after the impact, it was the long-term environmental fallout that truly devastated the dinosaurs and countless other life forms on Earth. The planet itself turned toxic. The asteroid's collision vaporized layers of limestone, releasing a staggering amount of greenhouse gases. 1 trillion tons of carbon dioxide, 10 billion tons of methane, and 1 billion tons of carbon monoxide. This cocktail of gases supercharged the greenhouse effect. But the devastation didn't stop there. The impact also vaporized anhydrite rock, sending 10 trillion tons of sulfur compounds into the atmosphere. This sulfur mixed with water, creating sulfuric acid, which then fell as acid rain. This rain was so potent it likely stripped leaves from surviving plants and leached nutrients from the soil, making recovery nearly impossible. Many researchers think dinosaurs went extinct almost immediately after the asteroid struck. But the truth is more complex. While many animals perished instantly and in the following weeks, particularly near the impact site, the global mass extinction took much longer and hit certain species harder than others. Surprisingly, some small mammals managed to survive. These resourceful creatures lived in burrows and had a diverse diet, giving them an edge in the post-impact chaos. Freshwater species also fared better than their land-dwelling counterparts, finding refuge in their aquatic environments. Researchers now believe that the KPG, Cretaceous, Paleogene, Mass extinction event struck a world already in trouble. Environmental changes had begun to challenge life on Earth, and the dinosaurs were struggling. Their world was cooling, food was becoming scarce, and competition was fierce. Ecological diversity dwindled as one species after another succumbed to the harsh conditions. Paleontologists acknowledge that the KPG extinction event still holds many mysteries. They puzzle over why some species died off quickly, while others managed to survive, and how the event affected ecosystems far from the asteroid's impact site. Regions like the American West, with its exposed rock formations, offer unique clues that might one day unlock these secrets. What are your thoughts on this ancient mystery? Drop a comment below, give this video a thumbs up, and don't forget to subscribe to our channel. Thanks for watching, and we'll see you next time.